geometry, we are covering CO9, identifying regular, convex, concave polygons using correct labeling, of course. That is very important when you get into geometry. So these works, convex and concave, some of you had experience with them in your homework because I accidentally assigned you some convex, concave questions, so perhaps you looked them up. But today we're going to officially define them. But we'll start with a regular polygon. What is a regular polygon? Andrea? No, so if a polygon is regular, it's got some specific characteristics to it, which is where the labeling comes into play.
Is it when all the degrees are the same?
Yeah, okay, so a regular polygon, all sides and all angles are congruent. All sides and all angles are congruent. So example of a regular polygon, we said the octagon that you're used to seeing is like a stop sign. That would be, if I can try correctly, a regular octagon. All sides, all angles are congruent, everything is the same. A square is a regular quadrilateral. Okay? An equilateral triangle is a regular triangle, right? It's when all sides, all angles are congruent. That's considered a regular polygon. Convex versus concave. What's the difference? Convex versus concave. Sam?
Oh, like a concave one, it's just like a polygon and like it's caving in almost. That's how I like it.
Okay. Polygon with sides that cave in. All right. How would you define it, Paisley?
I'm talking about convex or concave.
Sorry?
Convex,
Either one. Either one.
Isn't convex the one that like goes in like this?
No, that's concave. No.
That'd be concave. Andrea?
For me, like, if you imagine, like, each side has a line going through it, convex is when those lines, they don't go interfere through one of the polygon sides, but concave is when it does.
Okay, one more, Fultinsky.
It's kind of like it kind of extends out. Kind of, I guess.
Okay, like the size.
Like the sides, they kind of just extend out.
Okay, all right. All those things are all getting around it, but a convex polygon is a polygon with sides that, when extended, are on, stay on, yeah, we'll say stay on. No, remain. Remain on the exterior of the polygon. A polygon with sides that, when extended, remain on the exterior of the polygon. An example, what's that? Yeah, there is. It's right there.
Oh, thank you.
You have to learn his alphabet.
Sorry.
Yes.
Oh, I was telling Miss School about this.
Yeah.
Yep.
It looks like two.
No, that's my THE letters.
That does not look like two. Yeah.
It's like just
I
like
told her
same-
you need.
it's like
It's the same every time.
I told her that you need to like retake already.
So an example would be like that a pentagon that looks like home plate. Okay. If you were to extend any of these sides, they would all remain on the exterior of the polygon, right? All of these sides, if they were extended, nothing passes through. Okay, they all remain on the exterior outside of the polygon. That is considered convex. Okay, a concave polygon would be pretty much the opposite. A concave polygon is a polygon with sides that, when extended, pass through the interior of, that was a bad thought. Now I'm thinking about it. Now you got me all self-conscious.
Sorry, Mr. Schultz.
Yeah, that's okay. Of the polygon. I'm sure I'll forget by tomorrow. A polygon with sides that, when extended, pass through the interior of the polygon. Okay, an example of this one, let's write that down first. A polygon with sides that, when extended, pass through the interior of the polygon. So, if we had a pentagon that looked like this, right? If you extend one of these sides, it's got a side where if you extend it, it actually passes through the interior of the polygon. That's concave. Okay, Sam's example of kind of caves in on itself, right? Or you go inside of the cave, the extended segments would pass through the polygon. That would be concave. All right. Questions on the difference? Yes, Sam? No? Okay. I didn't hear your hand up. So now, oh yeah. Yeah.
Can I say something about
Sure.
a regular polygon?
Can you say something about what?
A regular polygon?
Sure.
A regular polygon is always going to be a convex.
Yes, a regular polygon will always be a convex polygon because with these types of polygons, you're not going to have those congruent angles.
So if it doesn't cut in,
Okay.
then it's not concave.
Correct. If it doesn't pass through the polygon, it is not concave, thus it is convex. Okay. Anything else? Anything else? So now we can classify polygons by their number of sides, okay? Whether they are regular or not, and then by their concavity or convexity. I think I just made those words up, so don't write them down, but we can do it. So it says draw and label each of the following. A regular octagon, we kind of drew one up above, but I'll be able to do it better now, bigger. This is your standard stop sign. Thanks, Paul.
Hold up. Just gave me a unique sweaty board name, like vexed, like sweaty does that sound.
What did I do?
Gave me a new sweaty board name. Vexed.
Vexity?
It sounds kind of sweaty.
That does sound. Wait, what does sweaty mean?
Like
Try
vexed
hard.
one. That's
Try
it's
hard.
a really good Fortnite player that
Oh,
can just
yeah.
Never leave the
Full
house.
box.
Yeah. All those things.
Thank you so much.
You're welcome. You're welcome. So here's the thing with the labeling. If I were to ask you to draw a regular octagon on the test, and this is what you gave me, I would have to mark it wrong. Because what with this shape tells me it's regular. What would you have to add to it to tell me it is indeed regular? Cormac. Right. You need the arcs on the angles to show me they're all congruent. And one other thing. Colin.
Congruency markers.
Congruency markers for the sides. Okay? Congruency markers for the sides. Now, in a polygon, if all sides are congruent, all angles will be congruent as well. So it may not have to be marked, both of them necessarily, but I want you to get that habit of it because we're still learning, we're still practicing. A convex pentagon, we actually drew one of those things too. Convex pentagon would look like this. And again, what makes it convex is that if you were to extend any of these sides, they remain on the outside of the polygon. Right, Darth? Thanks, Darth. Then a concave decagon. Let's let you, I've never let you people come up. Who wants to go and draw a concave decagon? Maddie, make it count.
Sorry, Nathan.
Maybe it was the, oh.
I think that would make it.
Any color you want. 2, 3, 4, 5. Decagon has how many sides?
Hold on.
She's got this. She's got it.
I just looked at the wrong one.
Do random stuff and make it go in.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is a concave decagon because when you extend these sides, right, it's going to pass through. Job well done, Maddie. Finally, a regular convex hexagon. Nathan, I owed you one. a regular convex hexagon in black. 1, 2, 3, 4. Uh-oh.
Wait, no. I don't get how you draw this stuff.
1, 2, 3, 4, 5, 6. Got the angle markers in there. Very good. The side markers coming next. Oh, look at that. Fantastic. All right. Darth, what do you think? Okay. Looks like a spider. Almost.
It looks like a packing
You like spiders?
Me? No. Then the last part here, it says classify each polygon by its number of sides and whether it's concave, convex, or regular. You're going to do this as part of your homework. In addition to your homework,
Mr. Schultz,
Hooray!
please.
Vexity, you just
Can we get 40? Wait, no, it's control Vexity. CTR.
40 pages.
page 45. I'd like you to do. Ooh, this looks fun. 18 through 23. How many questions is that?
6.
Good job. We're learning. And 28 through 30.
That's just 9 questions.
18
Oh, and there's
through
3.
23. 28 through
We get
30.
more.
You can do as many as you want to. That's how you math, folks.